JEE Main 22nd Jan, Shift 1 question. Let Z1, Z2, Z3 are the three complex numbers on the circle with mod Z is equal to 1. Argument of Z1 is given to be minus pi by 4. Argument of Z2 is 0. Argument of Z3 is pi by 4. Then if mod of Z1 plus Z1 Z2 bar plus Z2 Z3 bar plus Z3 Z1 bar whole square is equal to alpha plus beta root 2, then the value of alpha square plus beta square is. So given modulus of Z is equal to 1 and argument of Z1 is equal to minus pi by 4. Therefore, we know that Z1 will be is equal to modulus of Z1 into in e power I minus I pi by 4. We know that modulus of Z in general is equal to 1 and this therefore the value can be written as e power minus iota pi by 4 which is equal to cos pi by 4 cos of minus pi by 4 plus I sine minus pi by 4 and the value will be 1 minus I divided by root 2. Cos pi minus pi by 4 is 1 by root 2. Sine of minus pi by 4 is minus sine pi by 4 which is equal to minus 1 by root 2. Therefore, we get 1 minus I by root 2. Similarly, Z2 will be is equal to modulus of Z2, that is 1 into e power given it is equal to 0, e power iota into 0, cos 0 plus I sine 0, which gives us, which is equal to 1. Cos 0, 1, sin 0 is 0. And Z3 we know given in the question, argument of Z3 is equal to pi by 4, that is modulus of Z into e power iota into pi by 4. Cos pi by 4 plus I sin pi by 4, 1 by root 2 plus 1 I iota divided by root 2. 1 by root 2, that is cis pi by 4, cis by root 2. Therefore, we can write the value for Z1 bar. Given Z1 is equal to 1 minus iota by 2, therefore Z1 bar will be is equal to 1 plus iota divided by root 2. Z2 bar, the conjugate of the real number will be the same, which is equal to 1, and Z3 bar will be is equal to 1 minus iota divided by root 2. Now we are asked to find the value of mod of Z1, Z2 bar plus Z2, Z3 bar plus Z3, Z1 bar whole squared. Now we find the value for Z1, Z2 bar. Z1 we know is equal to 1 minus iota divided by root 2. Z1 bar is 1, so which gives us the value 1 minus iota divided by root 2. Now I find the value for Z2, Z3 bar. So Z2 is 1, Z3 bar is 1 minus iota by 2, therefore it gives us 1 minus iota divided by root 2. Next we want to find Z3, Z1 bar, which is equal to, so Z1 bar is 1 plus iota divided by root 2 and Z1 bar we know and Z3 is equal to 1 plus iota divided by root 2. So it gives us 1 plus iota whole squared divided by root 2 into root 2 which is equal to plus Z3 Z1 bar. Adding the first two numbers we get 1 minus iota divided by root 2 plus 1 minus iota divided by root 2 plus 1 plus iota the whole square divided by 2. Now this is equal to 1 by root 2 into 1 minus iota plus 1 minus iota plus 1 by 2 into 1 plus iota square is minus 1 plus 2 iota which is equal to 1 by root 2 into 2 minus 2 iota plus 1 by 2 into 2i. Now this is equal to 2 by root 2 into 1 minus iota plus iota. Again, this gives me this is equal to root 2 into 1 minus iota plus iota and further can be written as root 2 plus iota into 1 minus root 2. Now this is the value for only Z1, Z2 bar plus Z2, Z3 bar plus Z3, Z1 bar. Now taking the modulus, therefore modulus of Z1, Z2 bar plus Z2, Z3 bar plus Z3, Z1 bar, the whole square will be is equal to, that is modulus of root 2, the whole squared is 2. 1 minus root 2 the whole squared gives me plus 1 plus root 2 the whole square is 2 minus 2 into root 2, which is equal to 5 minus 2 root. Here alpha is equal to 5, beta is equal to minus 2, and hence, therefore, alpha squared plus beta squared is equal to 5 squared 25 plus 4, which is equal to 29. Let the curve z into 1 plus I plus z bar into 1 minus I is equal to 4 divide the region modulus of z minus 3 less than or equal to 1 into two areas as alpha and beta. Then mod of alpha minus beta. So given let z is equal to x plus iota y. Therefore from the expression value for z x plus iota y into 1 plus iota plus z bar x minus iota y into 1 minus I is equal to 4. So multiplying we get x plus iota x plus iota y plus I squared iota squared y, so that is minus y, plus similarly multiplying the, so here iota x iota y gets cancelled, we get 2x minus 2y is equal to 4, or the expression is x minus y is equal to 2. Now the next one, given that mod of z minus 3 mod of z minus 3 is less than or equal to 1, we know z is equal to x plus iota y. So x plus iota y minus 3 less than or equal to 1. Mod value is x minus 3 the whole squared plus y squared is less than or equal to 1. And this expression leads to the equation of circle with the center for the circle will be is equal to, so 3 comma 0, and radius is equal to 1. Now this equation is the equation of the circle with the center 3 comma 0, and this expression x minus y is equal to 2 is the equation of a straight line. Put a y is equal to 0, we get x is equal to 2, so the line intersects the x-axis at the point 2 comma 0, and the point of intersection of the line and the circle and this point will be is equal to 3 and 1. 3 minus 2, the distance between 3 and 2 is 1, and therefore the radius of the circle is 1, and therefore this point will be is equal to 3 and 3 comma 1. Now the radius of the circle is equal to 1 here. Let us take the shaded region to be is equal to alpha. Now let us find what is alpha here. Alpha is equal to area of, this is a quadrant. This is a quadrant. So this will be area of a quadrant minus area of triangle. Let us mark the triangle as some ABC. So the triangle is ABC minus triangle ABC. Now this gives us, this is equal to area of the quadrant of the circle will be is equal to pi r square divided by 4. So pi into r, radius is 1 the whole square divided by 4, minus area of the circle is half into base is the radius 1 and height is also 1, which gives us this is equal to pi by 4 minus 1 by 2. Now let us find the area of the unshaded region, which is taken to be is equal to beta. So now beta is equal to, we can take that as this can be considered as one quadrant, first quadrant, second quadrant, third quadrant, three quadrants, and plus we can take the part of the area of the triangle. This is area of the triangle. So we have three quadrants here. This part of the unshaded region taken as beta, and this is one quadrant, this is another quadrant, this is the third quadrant, three quadrants, plus we have this area of the circle. Therefore, beta becomes equal to, beta is equal to 3 times area of the quadrant plus area of the triangle, which is equal to 3 into pi r squared divided by 4 plus area of the triangle half into 1 into 1, which is equal to 3 pi by 4 plus 1 by 2. Find the difference of alpha minus beta, which gives us, which is equal to 3 pi by 4 plus 1 by 2 minus pi by 4 minus 1 by 2. I take the difference here, taking the modulus. So this gives me by 4 gives me 2 pi by 4, which is equal to pi by 2. 1 by 2 plus 1 by 2 gives me 1. So the difference of the area will be is equal to difference of the area is equal to pi by 2 plus 1. Those vertices are the origin and alpha comma 0 is 11. Area is given to be 11 square units. Then alpha square is equals to. So given mod of z bar minus iota divided by 2 z bar plus iota is equal to 1 by 3. So cross multiplying 3 times of z bar minus iota is equal to 1 into modulus of 1 into modulus of 2 z bar plus iota. Let us take z is equal to x plus iota y and z bar is equal to x minus iota y, and substituting the values we get 3 times of x minus iota y minus iota is equal to 1 into modulus of 2 into x minus iota y plus iota. Now separating the terms, this is equal to 3 times root of x squared plus y plus 1 the whole squared is equal to root of 2x whole squared plus 1 minus 2y the whole squared. Now taking squaring on both the sides, we get this gives us 3 times of x squared plus y plus 1 the whole squared is equal to 2x the whole squared plus 1 minus 2y the whole squared. Now this is equal to squaring on both the sides. This becomes 3 squared and this is 9. 9 times of x squared plus y squared plus 2y plus 1 is equal to right hand side 4x squared plus 4y squared plus 1 minus 4y. This is 9x square minus 4x square gives us 5x squared. 9y square minus 4y square gives us 5y squared plus 9 into 2, 18 plus 4, 22y plus 9 minus 1 gives us plus 8 is equal to 0. Now the equation is of the form x square plus y square plus 2gx plus 2fy plus c is equal to 0, which is equation of the circle where the center is minus g comma minus f. There is no x term here, so g is 0 and f 2f is equal to 22 and therefore f is equal to 11. From this we get the center of the circle where the center becomes is equal to 0 comma minus 11 by 5. Since the equation is having the coefficient of x and y, x square and y square as 5, we divide the equation throughout by 5, and therefore here according to this equation f becomes 11 by 5. So center is equal to 0 comma minus 11 by 5. Now coming to the question is the triangle has area of the triangle is 11 square units whose vertices are origin alpha comma 0 and the area is 11 square units. The given expression is equation of the circle. From the equation of the circle we have found the center C, where the center is one of the vertices of the triangle. According to the diagram, the center for the triangle is 0 comma 0. One vertex will be is equal to alpha comma 0 and to 11 units. Therefore, we know that area of triangle given to be is equal to 11 units, which is nothing but half into modulus of alpha into modulus of minus 11 by 5 will give us is equal to 11, which implies 5 into 2 is 10. Modulus of minus 11 is 11. Therefore, alpha becomes is equal to modulus of alpha is equal to 10. And therefore, alpha squared becomes is equal to 10 square, which is equal to 100. We are asked to find alpha square. The next question, the number of complex numbers is it satisfying modulus of z is equal to 1 and modulus of z by z bar plus z bar by z is equal to 1. So now the given expression, let us take z is equal to x plus iota y and z bar we know is equal to x minus iota y. Modulus of z by z bar plus z bar by z is equal to 1. Cross multiplying, we get here this is nothing but equal to modulus of z square plus modulus of z bar square divided by modulus of z bar is equal to 1. Modulus of z square plus z bar the whole square is equal to 1 divided by modulus of z bar, which is modulus of z bar will be is equal to modulus of z, which is equal to 1. So we can write it as modulus of z square plus z bar squared, and therefore substituting the values here, this becomes is equal to, which implies modulus of x plus iota y the whole square plus x minus iota y the whole square is equal to 1 of x square minus iota square y square is minus y squared plus 2 iota y plus x squared minus y square, that is iota square y square, iota square is minus 1, so minus 2 iota y is equal to 1. Now this is equal to modulus of 2x square minus 2y square is equal to 1, or which implies modulus of 2 into modulus of x square minus y square is equal to 1, or x square minus y square will be is equal to plus or minus 1 by 2 is one equation. Next we know that modulus of z is equal to 1. Modulus of z is equal to 1 implies x square plus y square also is equal to 1. So now this is the equation of x square plus y square is equal to 1 is an equation of the circle, and two cases we have for this. That is, case 1 will be x square minus y square is equal to 1 by 2 is one case, and case 2 will be x square plus y square, x square minus y square will be is equal to minus 1 by 2. Now this x square plus y square is equal to 1 is an equation of the circle with radius is equal to 1. If this x square minus y square is equal to 1 by 2, then this represents the equation x square minus y square is equal to 1 by 2 represents the equation of an hyperbola with transverse axis as the x-axis. Suppose the circle x square plus y square is equal to 1 and we consider x square minus y square is equal to 1 by 2. We have 4 points, and similarly, if x square minus y square is equal to minus 1 by 2 and the equation of the circle x square plus y square is equal to 1, here again we have 4 points for the circle. And hence the question is, find the number of complex numbers. Find the number of complex numbers. Is it satisfying this? So we have 4 points and we get 4 plus 4, 8 complex numbers according to our given question. Next question, alpha, beta are the roots of the given equation where iota is equal to root of minus 1. Then 16 times of real part of the given expression into imaginary. Divide the expression by z. So we get here 2 times of z minus 3 minus 2 iota divided by z is equal to 0, or the expression can be written as 2 times of z minus 2 iota by z is equal to 3. And again I simplify by writing 2 times of z minus iota by z is equal to 3 by 2. Or this can further be written as z minus iota by z is equal to 3 by 4 is equal to 3 by 2. Now let me square. Alpha is a root given. Alpha is a root of the given equation. Therefore, I can write this as alpha minus iota by alpha is equal to 3 by 2. Alpha squared plus iota square by alpha, that is 1 iota by alpha whole square. Iota square is -1, so minus 1 by alpha squared minus 2 iota will be is equal to right hand side 3 by 2 the whole square, which is equal to 9 by 4. Or I can write this expression as alpha square minus 1 by alpha square is equal to 9 by 4 plus 2 iota. Now again squaring on both the sides. Now again squaring on both the sides, we get alpha power 4 plus 1 by alpha power 4 minus 2 is equal to 9 by 4 the whole square, which is equal to 81 divided by 16 plus 2 iota the whole square, which is equal to minus 4 plus 9 iota. Alpha power 4 minus 1 by alpha power 4 is equal to 81. This is minus 2. So minus 32, 81 minus 32, which is equal to 49 divided by 16 plus 9 iota. Similarly, if beta is the root of the given equation, we also get beta power 4 plus 1 by beta power 4 will be is equal to 49 by 16 plus 9 iota. Now let us see what is the question given. Question is 16 times of real part plus into imaginary part is equal to, therefore alpha power 15 into combining these two alpha terms, alpha power 4 plus 1 by alpha power 4. Similarly, plus beta power 15 into beta power 4 plus 1 by beta power 4 divided by denominator is alpha power 15 plus beta power 15. Now substituting the value for alpha power 4 plus 1 by alpha power 4, that is 49 by 16 plus 9i plus beta power 15 into 49 by 16 plus 9i divided by alpha power 15 plus beta power 15, which gives us this is equal to 49 by 16 plus 9i can be taken outside and it can be written as 49 by 16 plus 9i into alpha power 15 plus beta power 15 divided by alpha power 15 plus beta power 15, which gives us this is equal to 49 by 16 plus 9i. Now I want the real part, and this is the real part of the given expression, and this is the imaginary part of the given expression. Therefore, 16 times of 2, therefore this term is equal to 16 times of 49 by 16 into the imaginary part is 9 here. So into 9, that is 49 into 9, which is equal to 441. Let O be the origin. Point Z1 is given and the point Z2 is such that root 3 modulus of Z2 is equal to Z1 and argument of Z2 is equal to argument of Z1 plus pi by 6. So this question represents these 3 points Z1, Z2, Z3 forms a triangle. Now according to the question, O is the origin and Z1 is one point where A is the point Z1 where Z1 is equal to root 3 plus 2 root 2 into iota, and the point is such that root 3 times modulus of Z2 is equal to Z1. Now let us see here that modulus of Z1 will be is equal to root of root 3 the whole square plus 2 iota the whole root 3 the whole square, which is equal to 3 plus 2 root 2 the whole square, which is equal to 8, we get is equal to root of 11. Now given in the question, root 3 into modulus of Z2 is equal to modulus of Z1, where modulus of Z2 will be is equal to modulus of Z1 divided by root 3, which is modulus of Z2 is equal to 11 by root 3. So we get modulus of Z2 that is which is equal to whole root of 11 by 3. Now OA this distance will be is equal to OB distance according to the diagram, that is root of 11 by 3, and OA is equal to modulus of Z1 which is equal to root 11. Now given that OA is equal to modulus of Z1 is equal to root of 11. Now OA is equal to modulus of Z1 which is equal to root of 11. OB is equal to root of 11 by 3. And now here this angle will be is equal to pi by 6. Now in the side AB. So AB square can be written as is equal to OA square plus OB square minus 2 times of OA into OB into cos of the angle between OA and OB which is equal to pi by 6. OA square, OA is equal to root of 11. So that is OA square will be 11 plus 11 by 3 minus 2 times of root of 11 into root of 11 by 3 into cos of the angle cos pi by 6 which is equal to root 3 by 2. Now this gives us this is equal by 3 minus 11 which gives us is equal to 11 by 3. Therefore AB square is equal to 11 by 3 which implies AB is equal to root of 11 by 3. Now from the diagram, the side AB is equal to root of 11 by 3. If this angle is equal to pi by 6, therefore this angle A is also equal to pi by 6. Since these two sides are equal, the opposite angles are equal, it forms an isosceles triangle. Therefore, the other angle, angle B will be is equal to pi minus of 2 times of pi by 6 which gives us which is equal to 2 pi by 3. So this angle will be is equal to 2 pi by 3, 120 degrees, and therefore now we get here the triangle from the given options. ABO is an obtuse angled isosceles triangle. Alpha plus iota beta, gamma plus iota delta are the roots of this equation. Iota is equal to root of minus 1. Then alpha gamma plus beta delta is 2 iota minus 2 is equal to 0. This is a quadratic equation, then therefore we know that x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So is equal to 1, b is equal to minus of 3 minus 2 iota, and c is equal to minus of 2 iota minus 2. We use the quadratic formula here. X is equal to minus b, so 3 minus 2 iota minus b plus or minus root of b squared 3 minus 2 iota the whole square minus 4 into 1 into minus of 2 iota minus 2 divided by 2. Now this gives me this is equal to 3 minus 2 iota plus or minus root of, expanding this we get 9 minus 4 minus 12 iota plus 8 iota minus 8 divided by whole divided by 2. Root of 9 minus 4 minus 8 gives us minus 3 minus 4i divided by 2. Now this is a complex number, and finding the square root of a complex number, the shortcut for finding, for example, root of a plus ib. I want to find the root of this number. This can be written as this is equal to plus or minus. The formula is root of modulus of z plus a divided by 2 plus iota b by modulus of b into root of modulus of z minus a whole divided by 2. Now I want to find the value of minus 3 minus 4 iota which is equal to plus or minus modulus of 3, modulus of minus 3 minus 4 is 5. So this gives me root of 5. A is minus 3 and B is equal to minus 4. So here this is 5 minus 3 divided by 2 plus iota into B by modulus of B. So minus 4 divided by modulus of minus 4 which gives me minus 4 by 4 is 1 minus 4 minus of minus 3 plus 3 divided by 2 which gives me this is equal to plus or minus root of 2 by 2, that is 1 minus iota into 8 divided by root 2, that is 2 root 2 divided by 2, which is equal to 2. So I can write this number as this is equal to plus or minus 1 minus 2 iota, this number whole divided by 2, or this is equal to 3 minus 2 iota plus 1 minus 2 iota divided by 2, or the number can be written as 3 minus 2 iota minus of this term, so minus 1 plus 2 iota divided by 2, or this gives me this is equal to 4 minus 4 iota divided by 2, or 2 divided by 4 into 1 minus iota divided by 2, or 1, which implies 2 into 1 minus iota, that is 2 minus 2 iota, or 1. 1 can be written as 1 plus 0i. Now moving on to the question, alpha plus beta I and gamma plus delta I are the roots of the given equation. Therefore, here these roots are given to be alpha plus beta I and gamma plus delta I. Therefore, here we can write alpha is equal to 2, beta is equal to minus 2. And similarly, gamma is equal to 1 and delta is equal to 0. Therefore, our question alpha, gamma plus beta, delta will be is equal to 2 into 1 plus beta is minus 2 into 0, which gives us this is equal to 2. Next question, modulus of z minus of one point, z2 minus another point. We find the minimum is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2. Now given modulus of z1 minus 8 minus 2 iota is less than or equal to 1, that is modulus of x1 plus iy1 minus 8 minus 2 iota is less than or equal to 1, or modulus of z1 x1 minus 8 plus iota into y minus 2 is less than or equal to 1. Modulus value, that is nothing but is equal to x1 minus 8 the whole squared plus y1 minus 2 the whole squared is less than or equal to 1. Now this represents the equation of the circle. This represents the equation of the circle with the center as 8, 2 and radius is equal to 1. Now let us see the next equation. Z2 is equal to x2 plus iy2. Therefore, modulus of z2 minus 2 plus 6i will be is equal to modulus of x2 plus iota y2 minus 2 plus 6 iota. This is equal to mod of x2 minus 2 plus iota into y2 plus 6. This is equal to, this value is less than or equal to 2. Less than or equal to 2. So this is x2 minus 2 the whole square plus y2 plus 6 the whole square is less than or equal to 2. Again, this is the equation of the circle with the center 2 comma minus 6 and radius will be is equal to 2. Now we have two circles, one circle with the center 8 comma 2 and another circle with center as 2 comma minus 6. So this must be 2 comma minus 6. Let us take this to be the points A and B. Now we are asked to find the distance between the two centers A and B. So what will be the distance between the two centers A and B, that is C1, C2 will be is equal to root of 8 the whole square plus minus 6 the whole square, which is equal to root of 64 plus 36 is equal to root of 100. So that will be is equal to 10. Now the distance between the 2 points, the radius of the first circle we know is equal to 1 and the radius of the second circle with center 2 comma minus 6 radius, this radius is equal to 2. Therefore, modulus of difference between Z1 and Z2 will be is equal to the distance between the centers A and B. This is the distance AB. So that is equal to 10 minus of 2 plus 1, which is equal to 10 minus 3, which is equal to 7 units. Next, another simple question. A, B belongs to the are integers, belongs to closed interval minus 3 comma 3 such that a plus b is not equal to 0. One expression is given and the determinant is equal to 1 and omega square are the cube roots of x square plus x plus 1 is equal to 0. Therefore, first let us solve. Now R1, I can write it as R1 plus R2 plus R3. So what do we get here? This is equal to z plus 1 plus omega square is equal to 0. You know the sum of cube roots of unity 1 plus omega square is now taking z outside we get 1 1 1 omega z plus omega square 1 omega square 1 and z plus omega. Now I can do C2 minus C1. I'm going to write C2 minus C1 and I'm going to change C3 the determinant. We get this becomes Z cube is equal to 1, or we can say Z is equal to 1 whole power 1 by 3. This denotes the cube root of unity, which says that the roots of Z are 1 omega and omega square. Now, which implies modulus of z minus a is equal to modulus of z plus b, and we know that a plus b is not equal to 0. Now let us take the first case 1. Let I take z is equal to 1. So what do we get here? This becomes modulus of 1 minus a is equal to modulus of 1 plus b, which implies 1 minus a is equal to plus or minus 1 plus b, which implies again 1 minus a is equal to 1 plus b, or this implies a plus b is equal to 0, or I get here a minus b is equal to 2. A plus b we know is not equal to 0 according to our question, and therefore we take the condition that a minus b is equal to 2. Now we know that from the question a comma b belongs to closed interval minus 3 comma 3. A comma b belongs to closed interval minus 3 comma 3. Now substitute all the values such that the difference is equal to 2. Now if I take the value for a is equal to 0, b is equal to 2. A is equal to minus 1, I get b is equal to minus 3. If I take a is equal to 1, we take b is equal to minus 1. A is equal to minus 2, b is equal to 4. Now what about this term? A is equal to 1, B is equal to minus 1. If I take A is equal to 1, B is equal to, if I take A is equal to 1, B is equal to minus 1, now gives me A plus B is equal to 0. So I cannot take A is equal to 1, B is equal to 1. And A is equal to minus 2 and B is equal to 4 is not possible because 4 exceeds the limit here. Now next we take A is equal to 3, we get B is equal to 1 is equal to 0. 4 cases, if I am going to take that Z is equal to 1 is the root for the given equation. So next root, if I take Z is equal to omega, the next case I take Z is equal to omega. If I take Z is equal to omega, then modulus of omega minus A is equal to modulus of omega plus B. You know that modulus of from the question modulus of Z minus A is equal to modulus of Z plus B. So here Z is omega, here I have taken the root. So now omega we know is equal to, it is a cube root of unity. So the root will be minus 1 by 2 minus I root 3 by 2 minus plus a plus b is equal to 0. Further, I can write this as a plus b into a minus b plus a plus b is equal to 0, which gives me this can be again written as further simplified taking that a plus b into the common term for these two. So the remaining terms are a minus b plus 1 is equal to 0. But we know that this a plus b cannot be 0 from our question. Therefore, a minus b plus 1 is equal to 0, which gives us a minus b is equal to minus 1. Now we have to take the sets of values for a and b from the interval, closed interval, minus 3, comma 3, such that it satisfies the given condition a minus b is equal to minus 1. Now let us take the sets of values taking if a is equal to minus 3, we get b is equal to minus 2. A is equal to minus 2, we get b is equal to minus 1. A is equal to minus 2, b is equal to, we get b is equal to minus 1. Next, we take the next set of value, that is a is equal to minus 1, b is equal to 0. Next, a is equal to 0, b is equal to 1. A is equal to 1, b is equal to 2. A is equal to 2, b is equal to 3. Minus 3, minus 2, minus 1, 0, 1, 2 taken. If we take a is equal to 3, b becomes equal to 4, which exceeds our limit we are not taking. So here, number of cases, 6 cases are here. Already, first case, if z is equal to 1, we have taken. If z is equal to 1, there are 4 cases. So total number of pairs here, the number of possible ordered pairs will be is equal to 4 plus 6, which is equal to 10.